Welcome to qnawire.
The regression equation is given as r sub I equals beta naught plus beta 1 s sub I plus beta 2 times m times b sub I plus beta 3 times p times e sub I plus beta 4 times beta sub I plus epsilon sub I. The obtained results are 0.080 plus 0.801 s sub I plus 0.321 m b sub I plus 0.054 p e sub I minus 0.084 beta sub I with standard errors in parentheses. And they are 0.64, 0.147, 0.136, 0.042, and 0.120. The t ratio for each coefficient is calculated by dividing the coefficient by its standard error. So for beta 1, it would be 0.801 over 0.147. I'll calculate that in just a moment. For beta 2, that would be 0.321 over 0.136. For beta 3, that's 0.054 over 0.042. And for beta 4, that's negative 0.084 over 0.120. And so we get about 5.45, 2.36, 1.29, and negative 0.70. Variables with low t ratios, typically less than 2 in absolute value, are considered less significant and might be candidates for deletion. Based on the t ratios calculated, beta 1 being 5.45 is significant, beta 2 at 2.36 is significant, but beta 3 and 4 are not significant, so they could be considered for deletion due to their low t ratios. The coefficient for beta is negative 0.084. If beta increases by 0.2 from 1 to 1.2, the expected change in the stock's return would be negative 0.084 times 0.2, which is negative 0.0168. So the stock's return would decrease by 1.68%. The sign of the beta coefficient is negative, which indicates that contrary to what might typically be expected, an increase in the stock's beta is associated with a decrease in the return model. Generally, higher beta stocks are expected to have higher returns to compensate for higher risk, so a negative coefficient might be surprising and could suggest an atypical relationship in the specific data set. Further investigation would be needed to understand why this is the case for these firms.